A person stands in a workshop late in the evening, looking at a half-finished project. A workbench is covered with printed pages, a tablet with paused videos, handwritten notes, and a few bookmarked browser tabs open on a nearby laptop. Each source explains part of the process. None of them fully connect. This situation is more common than it seems. Most builds today depend on fragmented information. One plan shows dimensions. Another explains joinery. A third demonstrates assembly in a video. The builder moves back and forth between them, trying to align steps that were never designed to work together. Under normal conditions, this system appears functional. Information is widely available. Tutorials are easy to find. Plans can be downloaded or printed. Each piece contributes something useful. But the structure behind this system is not unified. It depends on constant interpretation. There is also an external chain supporting it. Online platforms host the content. Creators publish their methods independently. Search systems connect the user to multiple sources. Devices provide access at each stage. When everything is available and working, the builder fills in the gaps through experience or trial and error. But when part of this chain breaks, the process slows down. A video becomes unavailable. A page is removed. Measurements don't match across sources. Steps are presented in a different order. The builder is left to resolve inconsistencies alone. This increases time, material waste, and uncertainty. To reduce this kind of dependency, people have developed different ways of organizing build information. Some rely on fully documented manuals. These are usually written as complete guides, covering the project from start to finish. They include consistent measurements, ordered steps, and material lists. The advantage is clarity. Everything is in one place. The limitation is that they may lack visual detail or adaptability. Others prefer video-based systems. These show the process in real time. Viewers can observe techniques and tool handling directly. This reduces ambiguity in execution. However, videos are harder to navigate. Finding specific steps often requires replaying sections. Measurements and variations are not always clearly documented. There are also modular systems. These break projects into independent segments. Each module can be built separately and later combined. This allows flexibility and reuse of parts. But it introduces complexity in alignment. Each module must fit correctly with the others, and small variations can accumulate. Another category includes interactive or digital platforms. These combine diagrams, animations, and sometimes calculation tools. They can adjust dimensions dynamically. While powerful, they depend on devices, software compatibility, and sometimes internet access. Within these categories, a more specific format has emerged. It focuses on keeping the entire build process within a single, continuous structure. Instead of switching between sources, the builder follows one integrated flow. This format is often built around a unified plan system. It starts with a complete material list. Each item is specified in relation to the final build. Dimensions are consistent throughout. There is no need to reinterpret measurements from different sources. The next layer is the assembly layout. This shows how each component fits together. It may include diagrams from multiple angles. The goal is to reduce guesswork during positioning. Then comes the sequence. Steps are arranged in a fixed order. Each action connects directly to the next. There is no need to search for missing transitions or fill in gaps between unrelated instructions. In some cases, the system also includes details about structural support, load distribution, or alignment checks. These are presented at the moment they are needed, not scattered across different references. This format can exist in different forms. Sometimes it is delivered as a finished device, already assembled and ready to use. In other cases, it appears as a build-from-plan system. These systems use common materials and standard tools. The builder follows the guide to recreate the structure from scratch. When presented as a build-from-plan system, the guide typically includes a full list of materials, a clear assembly layout, and a defined sequence of steps. It may also describe how components are arranged, how connections are made, and how power or mechanical systems are set up if relevant. The key difference is structural continuity. Everything needed to complete the build is contained within one framework. This reduces the need to interpret or reconcile external sources. For individuals working in small workshops or home environments, this approach can be practical. It minimizes interruptions. It allows the builder to focus on execution rather than coordination. It also makes the process more repeatable. Once the structure is understood, it can be applied again with fewer adjustments. At the same time, this format does not replace all other methods. Some people still rely on videos for technique. Others use modular systems for experimentation. The integrated format works as an additional layer. It shortens the distance between the plan and the finished result. In situations where consistency matters, or where access to multiple sources is limited, having a single structured reference can make a noticeable difference. It reduces dependency on external links, platforms, or fragmented information. There are structured guides that document this type of system in full detail, showing each stage of the build from beginning to end. For those exploring this approach further, one such format reference is commonly included in the video description, where it can be reviewed as part of independent research.